Welcome back, everyone. In today's episode, we're tackling proxies for ML and AI training data collection. I've put together a really thorough breakdown for you, covering everything from the basics to some advanced strategies. Let's do this. Building high-quality machine learning models requires massive, diverse training datasets, and proxies for ML training data collection are the infrastructure backbone that makes large-scale web data gathering possible. From scraping image datasets to collecting multilingual text corpora, proxies enable AI teams to gather training data without hitting rate limits, IP bans, or geographic restrictions. This guide covers how to set up proxy infrastructure for ML and AI training data collection at scale. Why does ML training data collection need proxies? Training modern AI models requires datasets with millions or billions of data points. Collecting this data from the web presents unique challenges. Volume, because you need millions of samples requiring sustained high-throughput scraping. Diversity, because training data must represent diverse sources, languages, and perspectives. Geographic spread, because models need data from multiple regions and cultures. Freshness, because some models require up-to-date data from rapidly changing sources. And quality, because raw data needs to be collected consistently without site-specific biases. Let's talk about choosing the right proxy type for ML data collection. Datacenter proxies work best for bulk text collection from less protected sites. They're the cheapest option at high volumes and offer the highest speeds. Residential proxies are essential for scraping protected platforms like social media, news sites, and e-commerce. They're harder to detect and block. Mobile proxies provide the highest trust level and work for collecting data from mobile-first platforms. And ISP proxies offer a balance between data center speed and residential trust. For a recommended architecture, a typical ML data collection pipeline uses tiered proxy pools. The first tier is data center proxies for initial discovery and URL collection. The second tier is residential proxies for actual content extraction from protected sources. And the third tier is mobile proxies for high-value targets that block everything else. This tiered approach optimizes cost while maintaining high success rates across different target types. Now let's look at specific ML data collection use cases. For text corpora collection, training large language models requires diverse text from many sources. The approach involves collecting URLs from search engines using data center proxies, then extracting article text using residential proxies for news sites and protected content, storing raw text with metadata, including source URL, collection date, and language, and deduplicating across sources to ensure dataset quality. For image dataset collection, training computer vision models requires millions of labeled images. The approach involves using search engines and image databases to find image URLs, downloading images through rotating proxies to avoid rate limits, collecting associated metadata like alt text, captions, and surrounding context, and validating image quality and relevance before adding to the training set. For multilingual data collection, building multilingual models requires content from many languages and regions. Geo-targeted residential proxies let you access localized versions of websites from different countries. This ensures your training data represents how content actually appears to local users. For social media data collection, training sentiment analysis, content moderation, or recommendation models often require social media data. Residential and mobile proxies are essential here because social platforms have the most aggressive bot detection, use sticky sessions to maintain realistic browsing patterns, and respect rate limits since getting proxies burned on social platforms is expensive. Some best practices for ML proxy infrastructure: use connection pooling to maximize proxy throughput, implement automatic retry with different proxy pools on failure, monitor success rates per proxy pool and target site, track costs per successfully collected data point, set up bandwidth budgets to prevent runaway costs, and log everything for dataset provenance and reproducibility. For cost optimization at ML scale, proxy costs can become significant at ML data collection volumes. To optimize, use the cheapest proxy type that works for each target, cache aggressively to avoid refetching the same content, deduplicate URLs before fetching to eliminate waste, use incremental collection to only fetch new content, and negotiate volume discounts with proxy providers for sustained large-scale usage. Some ethical and legal considerations specific to ML data collection: respect robots.txt in terms of service, consider copyright implications of collected content, implement data retention policies that comply with privacy regulations, document data provenance for model transparency and reproducibility, and consider the environmental impact of large-scale data collection. Now for some frequently asked questions: how many proxies do I need for ML data collection? It depends on your volume and speed requirements. For collecting 1 million pages, you might need 1,000 to 5,000 rotating residential proxies. For 100 million pages, you might need 10,000 to 50,000. Start small and scale based on actual success rates. Which proxy provider is best for ML data collection? For high volume work, Bright Data and Oxy Labs offer the largest proxy pools and best infrastructure for sustained high throughput collection. For budget-conscious projects, IP Royal and Smart Proxy offer good value at moderate volumes. How do I handle rate limiting across thousands of target sites? Implement per domain rate limiting in your crawler. distribute requests for the same domain across many proxies, use exponential backoff when rate limited, and maintain a priority queue that rotates between domains. Can I use free proxies for ML data collection? No. Free proxies are unreliable, slow, and often inject content or steal data. For any serious ML data collection, invest in quality paid proxies. The cost per data point is negligible compared to compute costs for model training. That brings us to the end of today's guide on proxies for ML and AI training data collection. I packed a lot into this one, so if you need to, feel free to come back and listen to certain sections again. And if you want even more resources, dataresearchtools.com has hundreds of articles on proxies, scraping, automation, and more. Thanks for tuning in, and I'll talk to you soon.